Okay, I've got two triangles right here. In this triangle right here, I drew a line from the vertex perpendicular. I could have drawn it from C perpendicular to this side or from B perpendicular to this side. I just decided just to draw one of them. Okay, Zach, you getting all this? Why don't you get some notes out, get some paper out. Why don't you start writing this down then? All right. Blake, get your head up right now. Actually, how would you feel about sitting back there? Is that all right? You can do that? All right, switch. Right here. All right, this thing right here is called an altitude. Write it down. We've already discussed this word before. We had a whole section. Okay, I don't want to hear anything. We had a whole entire section about this, and it's just perpendicular to the opposite side. What we're going to do here is draw an altitude on this one as well. Kel, enough, okay? I know, but you're laughing about every little thing that happens, and it just encourages them to do silly stuff, all right? Because you laugh every single time they do something dumb, all right? So I'm not blaming you. You're just encouraging them for bad behavior, okay? All right, so here we go. And let's call this D, and let's call this J. Blake, any day, come on. I understand. Just do it quickly. All right, let's take a look. We're going to actually do this 3 times with 3 different segments of a similar triangle. The first segment is the altitude. We're going to do 3 of them. This is the first one. Put a 1 there if you want to. This is an altitude. An altitude goes from a vertex perpendicular to the opposite side. Now watch this. I'm not going to go through a proof and show you exactly why this is true. We could probably work something out, but I'm not going to, and I don't think you really care that much about it anyway. So what I do care about, though, is that you understand that the proportions that are going on. So what this theorem says, there's 3 different theorems. And let's see. It says, if 2 triangles are similar. So let's start off, first of all, saying that the triangles are similar. So this is triangle, we'll call this ABC. So we'll say that triangle ABC, what do you think? It's drawn exactly FGH. All right, so FGH. So it's given that they are similar to each other. All right, we don't have to guess they are. They tell us in the book that they are similar to each other. Yes? Okay, we've had that discussion. I'm not going to answer that question. All right, well, sorry, we already talked about it. We're having it tomorrow. All right, let's keep going. What this theorem says is this. It says that the altitudes are proportional to the corresponding sides. You hear me? The altitudes are proportional to the corresponding sides. So when we set up a proportion, we set up ratios, don't we? Fractions. So that means the ratio of this altitude to this one is going to equal the ratio of the corresponding sides. All right, so let's set it up. What are altitudes? Well, it's AD. So what am I going to do? I'm going to compare this triangle to this triangle and all these segments. So what am I going to compare? I'm going to compare altitude to altitude. So AD to what? FJ. Right? So I'm comparing the altitudes, right? Tell you what, let's do the other ones in yellow. So the pink ones or purple, whatever the color that is, those are my altitudes. Now, it's proportional to the corresponding sides of the triangle. So which ones are corresponding sides? Like AB. Let's start with AB. What triangle over here corresponds to AB? FG. Now what if you couldn't really tell? Now this was pretty simple, okay, because I copied, pasted. Everything matches up perfectly on this one. But what if I took the one triangle, twisted it, flipped it, and you look at it and you're like, you know what? I'm not really sure what angle goes with what. What could you always go to? At this thing right here. What do we call this? We call this the similarity statement, right? The similarity statement. So look, which one, just by looking at this statement, which one goes with AB over here? FG. Do you see that? So even if I took this and flipped it around and all that kind of stuff, I would know which one goes with AB. AB is the first 2, FG is the first 2. So AB to what? FG. Does that make sense? And so it's corresponding to all of the, or it's proportional to all the corresponding sides. So watch, AB to FG. What other sides do I have? Okay, yeah, I started writing A first. We'll go AC. So if I compare AC, what would I do it over here? FH. I don't even have to look at this triangle, do I? That's what's nice about this similarity statement. So I can go, what did I say? FH, right? And what's the last one? I did AB and I did AC. What's next? BC, right. So let's compare BC to what over here? GH. You get the hang of that, don't you? That's pretty easy to see. And there it is. So those are all equal to each other. Now, you know what they're going to do, don't you? They're going to put numbers here, right? They'll probably give you 3 of the 4 lengths that you need. So you just stick the numbers in, do a little cross multiply, and then solve for whatever you need to solve for. Okay, we'll do an example at the very end, all right? We're not going to do all 4 of them. You're just going to compare 2 of them. So I would go this one to this one. It depends on which ones they give you numbers, okay? So if they told you AD and FJ, and they told you AB, but they didn't tell you FG, then you can just use these 2. So basically, you would just pair them up, all right? Does that make sense? All right, so that's an altitude. That's something a little different that we haven't talked about. We haven't talked about the segment inside the 2 triangles. This is the first time that we talked about those 2 segments, okay? All right. I mean, knowing this, I hate to keep beating this to death, but watch. Knowing this thing right here, we already knew that the all this stuff was true, didn't we? We already knew that stuff because when they're similar, all the corresponding sides are in proportion. We already knew that. What's the one thing that we didn't know? We didn't know anything about the altitudes. All this theorem is saying is that, hey, all 3 of those corresponding sides are in proportion, and so is the altitude. So just stick the altitude on there as well. That's basically all it's saying. You got it? Okay. Now, that was altitude. Now, remember that chapter that we did circumcenter and orthocenter and all that good stuff? We're going to do the same thing. We talked about altitude, but then we also talked about some other things. What was another one?
Vertex.
Well, vertex has a lot to do with a lot of things we're doing in here, but it's a what? Angle bisector. So let's talk about an angle bisector. The triangle looks a little different. I mean, you could use any of the triangles that I've been using here, but I'll just draw mine so it kind of looks like theirs. All right, so I'm going to copy and paste, and I'm going to just shrink it down a little bit and just move it over here like this. All right, we good? And let's label the thing. Let's label this QRS, and they call us KLM. Again, I'm just staying consistent with the book. All right, and it tells you that the triangles are similar to each other. So QRS is similar to triangle KLM. Okay, they told you that right there. You didn't have to guess. You didn't have to figure it out. They told you that those triangles were similar. We good? Now what we're going to do is we are going to draw the angle bisector. Let's do that in orange. So the angle bisector does what? Does that necessarily go to the midpoint of the opposite side? Is that angle bisector? No, we're taking this angle, for instance. I could have started at Q, I could have started at S. It doesn't matter. I just decided to start at R. Why did I do that? Well, because that's where the book did it, okay? So that's why I'm doing it there. So watch. R right there. I got to bisect the angle. Does that look bisected? No. Does that look bisected? No. Tell me when. About right in there, right? Maybe like this?
Yeah, right there.
Okay. Now look, it kind of looks like it's hitting the midpoint of this side right here. Yeah, it's pretty close, but it doesn't have to hit the midpoint of the opposite side. Okay? It's the what? Angle bisector. So I'm bisecting this angle right there. Everybody see that? Let's change colors. I don't know why it went back to blue. Oops, let's try this again. There we go. And let's do that one more time to this one. Sorry about that. There we go. All right, so that's an angle bisector. Guess what we're going to do over here? Do an angle bisector over here. And that kind of looks maybe about like that. And so that means that these 2 angles are equal to each other as well. All right, now watch this. This looks very, very similar to, well, not to have a pun on this thing, but let me scooch that up a little bit. This looks very similar to what we just did before with the altitude. Remember that? Except it's not perpendicular to the opposite side. What does it do? It bisects this angle. But the angle bisector is also proportional to the other 3 sides, the corresponding sides. So let's set that up. Now we got to put a letter here, don't we? They say this is T, and this one is P. All right? So let's set that up. What can we do? We can say that RT over what? LP. That's right. Because look, you're taking the two angle bisectors. This orange line right here is my angle bisector. So if I take the ratio of that angle bisector, it's equal to the ratios of the other corresponding sides. That means they're in proportion, right? So RT to what? LP. So that's the ratio of the two angle bisectors. Just like we did up here. Whoops, a little too far. Right here, right? We took the... I always forget the name of that one. The altitude. We took the altitude. We compared this altitude to this altitude. So guess what we're going to do with the angle bisector? Compare this angle bisector to this angle bisector. All right? So I do that. And let's do the rest in blue since it matches up. And now I can set it proportional to the corresponding sides. Let's do that a lot quicker than we did the other one. So I could go what? QR over KL. And then I could go QS over what? KM. And then the last one would be what? RS. And compare that to LM. Alright, so I could use any of those right there. That's all there is to it. Very, very close to that altitude thing. Alright, so we did altitude. We did angle bisector. Remember I said we were going to have 3 of these? And let's do the last one. Let's see, what would be a nice... Let's go with this nice green. So the third one is called the median. Do you remember the median? What do you do for a median? Well, no, that's like a... That's an arithmetic median. We're doing geometric medians. What? Because that's the third one. We're doing 3 of them. 3 different segments. Alright, so I copied, pasted. I'm going to shrink this one down a little bit. Right there. Okay. I'll go a little faster on this because I think you're getting the hang of it now. So this is A, B, C. This is WXY. Alright, and then let's do the median. Now, where in the world is the median? If we start from, let's start from C. We start from C, where do we go? Does a median bisect this angle? Is that what that is? No, that would be an angle bisector. Alright? Does it go where? Does it go here, here? Where does it go? Median. Think of median. In the middle. Give me a better geometry word than middle. Midpoint. Midpoint. In fact, let's find where the midpoint would be. That would be right there, wouldn't it? Okay, that would be the midpoint. So I'm going to, what color was I using? Yellow. Yellow. Well, for this median, I'm going to use yellow. Look. So, right there, I just drew the median. How do I know that's the median? Because it hits the opposite side at its what? At its midpoint. Put the 2 little marks right there to show those 2 segments are equal. And I do the same thing over here. Alright, so the midpoint would be right here. Let's grab this color. And then I'm going to go from Y to this midpoint, and there you go. I've got 2 medians. And let's see what letters they use. They use D for this one and Z for this one. Alright, so let's set it up again. You should be used to it. You've seen this twice already, so this one should make sense. If I just told you to write down all the proportions, you should be able to sit there and write these proportions down according to what we've done 2 times previous to this. Would you agree? So somebody talk to me. What do you think the first thing I'm going to do? I'm going to compare the 2 medians. Yep, DC, or let's go CD. Compare it to what? YZ. YZ, good. I like everybody answering at the same time. That sounds good. And then, what else? Oh, first of all, I didn't do this. I didn't say what triangles were congruent. What do you think? ABC. Not congruent. Why did I say congruent? Similar. ABC and what? WXY? Okay. So that's what they give you. They tell you that they're similar to each other. So, what do I do? AB to what? I mean, you could look at the picture if you want, but I like looking up here, to tell you the truth. AB to WX. What else? AC to WY. And last one, BC to XY. You're getting used to that now, aren't you? So there you go. So those are all the things that are proportioned. How are we going to use this? Well, we're going to use it because they're going to put numbers in here for these. And you just have to stick the numbers in, figure out the proportion, do a little cross multiply, and bang, you're done. Plug and chug. And that's not really plug and chug, but it's just cross multiplication. Now watch this. Let's scooch this out of the way here. And let's grab all this, group it together. Now watch this. If I could get everything ready. Now I'm ready to go. They could take this and kind of twist it around, couldn't they? Maybe like that. Now I understand that the letters are all upside down and stuff. It doesn't matter. Look at this. If they did this, sometimes it's a little bit more difficult to see which segment goes with what. Would you agree with that? I mean, it's hard to tell. So how do you know that what AC goes with over here? I mean, does it look like it's that one? I don't know. Sometimes it's hard to figure out which one that this one goes with. So what do? You end up going back to this. So this similarity statement is really, really important for you, because if you look at the picture, if they twisted it and flipped it, and you can't really say, does that side go with this one or does that side go with this one? I don't know. I can't really tell by the picture. So what do you go by? You go by the information that was given, or the information that you should have been able to figure out.
Is there always going to be a similarity statement?
Well, sometimes you might have to figure out the similarity statement. And the example that we're going to do, we're going to have to figure that one out for ourselves. Okay? So that's what we're going to do right now. Okay, here's two triangles, and it doesn't even say that the triangles are similar. It doesn't say anything about them. All it does is say solve for x. And you're like, well, where's x? Well, we're not talking about this angle. I haven't finished putting stuff on here yet. So let's put some stuff on here. What they're doing is they take from here and they go up here like this, put a right angle. So what did I just draw right there? What is that thing?
Altitude.
It's an altitude. Very good. And from y, it's dropped to here. And guess what that is? That's an altitude. They don't look equal? What do you mean? What do you mean equal? What do you mean? They're not supposed to be equal. They're not supposed to be equal. I'm not sure what you're saying. Right, they are proportional. Okay, that's 15. This is x. And this has one arc, and this has two arcs. Okay. Remember, they don't have... Jonathan asked me before, will they always give you a similarity statement? In this situation, they do not give you a similarity statement. You have to come up with your own similarity statement. So let's take this triangle right here. That's the first thing I would do. Before I start doing any math, before I start comparing anything, I would write the similarity statement down, because to me, that's very, very helpful. Okay? You can call this whatever you want as far as these three letters are concerned. Let's just call it KLM. Is that all right? So if I call this KLM, come down here. It's kind of flipped around, isn't it? So we have to figure out which order are they going to be in. Well, look what I did. I went from K, which has one arc, to L, which has two, and then to M, which doesn't have any. You see it? So I got 1 to 2 to none. So what am I going to do over here? 1 to 2 to none over here. So X, Z, Y. So triangle X, Z, Y. Does that make sense to you? Okay. This is really important. So it tells you what side goes with what. Look, KL up here goes with what on this one? XZ. This bottom one. This top one corresponds to this bottom one. You see it? What? KM. KM is this left side. It corresponds to what? KM, XY. So it corresponds to this one right here. You see it? So the 20 goes with the 15. Make sense? All right. That's very helpful. So let's set up a proportion. First of all, let's do a ratio for the altitudes first. So what are my altitudes? 16 to what? To x. So I compare 16 to x. Now what I have to do is I got to compare two sides that I know. Well, let's use 20. Now let's just double check and make sure that 15, I mean look, 15 on this example is probably about your only choice, right? Because you don't know any lengths to the other side. But let's just make sure. Does 20 and 15, do they correspond?
Yeah.
Yeah, because 20 is KM. Watch. KM is that one. And then over here, 15 is XY. So it's that one. Yeah, they do correspond to each other. Here's another way to look at it. Watch this. See what angle 20 is opposite?
Two arcs.
It's the one with the two arcs. Look at 15. 15 is opposite the angle with the 2 arcs. So that's 2 ways to look to see which sides correspond to each other. Does that help at all? Okay. So what is it? 20 to what? 15. All right. Now what do we do to solve for x? Cross multiply. Okay. So what do I get first? 20x equals. Now look, you could put that into a calculator if you wanted to, but I'm going to show you how to do this without a calculator. It's not that hard. Okay. It's basically just crossing stuff out. You learn that in like 4th or 5th grade. I don't know. So watch. Divide by 20. Right? So x equals, look, I didn't go 16 times 15 because I can't do that in my head. All right, I could probably put it in a calculator or something, but I don't know what 16 times 15 is off the top of my head. So what I do is I put this over 20, but look, I do have stuff that'll cancel out here. Look at the 15 and the 20. What cancels out with 15 and 20? What? Look, okay, we've had this discussion the other day. I'm not going to go into a big spiel about this, but listen to me. We have to get over the fact that you say it's confusing. This is stuff that, I'm not trying to make you feel bad. I promise. I'm really not. But this is stuff you did back in 5th grade. 5th and 6th grade probably. You did this kind of stuff. All right? I'm just trying to bring it back to your memory a little bit. Abby, put the calculator away. Put it away. Put it away. I'm dead serious. I'm serious about this, okay? You need to learn how to do some basic arithmetic, and that's what this is. This is just basic 5th, 6th grade arithmetic. So look, don't tell me, Brett, I don't want to hear it out of your mouth again that this is confusing. All right? Keep it to yourself because it just brings everybody down. What you have to do is you have to say this. Listen to me. Are you listening? What you have to say is, okay, he's showing me a new way to do it. I could probably do it in my calculator, but I want to see how he does it because maybe I can learn something today. That's what your thought should be. All right? So look, I got a 15 on top and a 20 on the bottom. What goes into both of those? 5. 3 doesn't go into 20. Look, 5 goes into 20 how many times? 4. You remember doing this when you were a kid, don't you? 5 goes into this how many times? 3. Are we done? No, because look, I get a 16 on top and a 4 on the bottom. 4 goes into both of those. 4 goes into that once. 4 goes into this 4 times. What do we do now? It's multiplication, isn't it? 4 times 3 is 12. Look at that. Without a calculator. Aren't we brilliant? Okay? We can do a little math problem without a calculator. Say what? By myself. Come on. That's 5th grade stuff. All right. So here's what you're going to do. Listen to me. Shh. Settle down. I know that was exciting. It's the first time you did a cross multiply problem. Okay. Watch. So section 7.4 is. I'm sorry. I lied. It's 7.5. Okay. Worksheet is 7.5. I'll give it to you right here in a second. So that's going to be due tomorrow. All right.